Yeah, hello all, and I welcome you all to this presentation. My name is Harsha, and I'm together with my two colleagues, Shobha and Fernando. And I'm operating as head of text analytics in a central function called as Merck Office. And we are striving to provide a central data analytics ecosystem for the whole organization. And Shobha works as a lead big data architect for finance, and she works in an adjacent function called as Group Functions Data Office. And we are representing Merck in Darmstadt. And then we have Fernando, who is operating as an external contractor for NLP. And today we have a use case which is in the area of NLP for finance. That is, we'll be showcasing you how we apply NLP and machine learning techniques for automatic categorization of the invoices to be more compliant with respect to the submissions. So before we get into the details, a quick introduction to our organization. So Merck is a vibrant science and technology company. It is headquartered in Darmstadt in Germany, and we are known as EMD Group in US and Canada. And Merck is into three areas of business: healthcare, life science, and electronics. In healthcare, we design and develop medicinal products and smart devices for the care of patients. In life sciences, we develop tools, we offer services and expertise to cater the needs of pharma, biotech, diagnostics, and other life science companies. And in electronics, we develop materials and solutions to cater the needs of electronics companies. And when it comes to the NLP, we have seen a profound application of NLP in terms of application towards across multiple sectors and different business areas. And if you look at it from a end-to-end value chain point of view, so be it early research, be it development, in the testing phases of the product, for example, clinical trials, or in the manufacturing processes, or be it post-market surveillance, we see that NLP can be applied in a quite broad domain, and to be able to extract valuable insights and information from unstructured data, which could subsequently expedite business processes, could help in valuable decision making. And here are some of the examples that I have listed where we have seen a potential applications of NLP. For example, we see applications of NLP in the area of legal, for example, right, where we are able to apply NLP techniques for analyzing the contracts, and so that we are able to find legal clauses that has been mentioned in the multiple contracts. We have applied NLP in the research domain to be able to find research articles, to help our experts and scientists to be able to find articles that are relevant for their area of work. We have found applications of NLP in the regulatory domain, for example, where we are applying NLP to structured, unstructured contents, mostly regulatory documents, so that we are able to expedite the process of submission of information to the health authorities. We see applications in the areas of post-market surveillance, for example, analyzing the inbound data, for instance, customer inquiries coming from multiple channels, medical science liaison communications, patient advisory board data, right? So that we are able to understand the voice of customers and voice of patients as well. If you look at it from the manufacturing domain, then we apply NLP to analyze the manufacturing deviations, manufacturing problems, so that we are able to now help our manufacturing colleagues to identify proper investigations, and they're able to streamline the process of manufacturing. We see applications in the area of clinical trials, for example, analyzing the monitoring visit reports, so that we are able to find any kind of anomalies, any kind of non-conformances that we are observed in the clinical trial sites. And of course, the PFDD, patient-focused drug discovery, is something quite hot field as well, trying to analyze the social media data to understand the voice of patients, voice of customers that has been expressed in online forums and online channels as well. And last but not least, NLP for finance, where we apply NLP to categorize the invoices automatically, so that we are able to be more compliant with respect to the submission processes. With this, I hand it over to Shobha, my colleague, who is going to take us into the more details of this use case.
Thank you, Harsha. So let's familiarize with the business use case to begin with. The Deutsche Bundesbank, which is the German central bank, for regulatory reasons, mandates all cross-border invoices to be categorized in predefined state central code, which we refer to as SCB code. So any cross-border transaction will have to be categorized as per the regulatory requirements. And these codes are published by the bank with supplementary explanatory notes section, and it's made available to organization. So let me give an example. Hypothetically, for example, say if we have a telecom company with a transaction that has a cross-border implication, then we need to slot anything to do with with such invoice, rather, I would say, the telecom company, in, say, code SCB 576, just to give you a example. So if, say, there's another invoice which is to do with IT services, again, that's to do with cross-border transaction, then that would be slotted in another SCB code, and so on. The penalty for slotting an invoice into the wrong code is severe, and the penalty applies for per miscategorization of the invoice. So therefore, it's really key that we address this process. So let's look at what the process is currently. Right? In the current process, everything is manual. It's effectively accountants on a monthly basis. They receive invoices from cross-border transactions, and they have to literally slot. They have to know there's a 600-page document where you have all the SCB codes, and they need to literally slot each one of those cross-border transaction into a particular designated, pre-designated, agreed SCB code. So the whole process is manual, monotonous, repetitive, and there's about 27 accountants involved, clearly prone to human error. And say if an accountant newly joins in, then he doesn't have the pre-knowledge, and it's very easy to slot an invoice in the wrong category, because there's also a time pressure when they receive, from the point they receive to the point they have to deliver this invoice labeled in the correct category. So to solve this problem, clearly, machine learning automation seemed the way to go about to categorize our invoices. And the benefit is to mitigate the regulatory compliance risk and therefore the penalties. So before we dive deeper into the machine learning model, what kind of models we're using and so on, let's look at the overall high-level architecture for this, for the solution that we are currently using. So before we go even deeper into all these boxes that you see, I would like to familiarize you with the different application environments. So typically, we have something called as a factory environment. So we have a proprietary cloud, and the proprietary cloud has got virtual silos. It's kind of, and the virtual silos is called a factory environment. Now, each factory environment is specific to an application. So what you see there are two factory environments, NLP factory and Bundesbank factory. Now, Bundesbank factory is an environment that is designated to build this application, to automate this application in a proprietary cloud. And you have NLP factory environment. The NLP factory, the NLP as an application, it provides NLP services, it's platform as services, but around NLP to various departments in the organization. So therefore, there's also lots of benefits to using NLP factory environment, because there's also opportunities to scale an application. And therefore, so at the moment, to put in a nutshell, we have factory environments. And then we also have something called as a lab environment. Now, lab environment is where the data scientists, they train the models. So what is the difference between factory and lab? So lab environment is very, very light on engineering, so that the data scientist can focus purely on the model training. So we have SageMaker here, and a lot of automation is done for the data scientists so that they can play with the model. So effectively in the cloud environment, you have two types of environment: a factory environment, a lab environment. And of course, the cloud also has an enterprise storage area. So now let's begin with the flow. What you see at the bottom, the box at the bottom, that is our backend SAP system. And so every month, all the invoices that are categorized, along with the labels, that is kind of fed into the storage area. So these are golden labels. So we know pre-designated, okay, these invoices have been processed and they're categorized into the correct labels, and these feed into the cloud environment in the storage space. So once this is done, an email is sent out to data scientists to inform that the data is ready, And whenever the data scientist chooses to train, depending on the model accuracy, which we've already shipped out, we'll then go into the data science lab environment and start training the model. So once a model is trained, there are multiple outputs. One is he could have tweaked the machine learning library, which means there is a change in the code. And the output of the model is typically there are two files, .pickle that comes out of model training and .model that comes out of encoding. And so these three components have to be then shipped into the factory environment so that the model can serve. So and the way this happens is through CI/CD pipeline, Azure DevOps. All three, they move from the lab environment into the factory environment. So the factory environment has its storage. That's where your model and your pickle file goes in. And the code repo, so we have a Docker container, which is in the factory environment, and any change to the ML component through the code repo is then injected into the Docker environment. So in the Docker environment which is used within the factory environment, is mainly to serve. It's a model serve. And therefore, there are multiple components. We'll just walk through it quickly. So you have one API which receives PDF, and it sends it to the proprietary OCR library. The proprietary OCR is the same OCR library which is used within the lab environment. So PDF is then converted into text, which is either text, and then it's sent to the ML API. ML API actually knows exactly what sequence of steps to call in, and then it sends this text to the ML library, and then it gets the inference. Now, the inference or the SCV codes, we provide the top three SCV codes for the text. So there's rankings as well as the codes that's written as a result. So that's the process that's within the NLP factory. Now let's look at on the right side. So an accountant, he drops his or uploads his documents using the web. It's a reactive user interface, and uploads his documents into a storage area within the Windows factory environment. And then we have serverless functions which handles the whole process. So the first part is when the document is uploaded within the storage area, there's a unique ID that is returned to the user. And then the user uses this unique ID to poll into the database for results. He's waiting for the results through and using another serverless function to just poll for the results. Meanwhile, the document which is stored within the storage, it's then sent. There's another serverless which picks up this PDF document, sends it to the factory environment, gets the top three results back, and the results are then added along with the user, the unique ID, the results, and the ranking. All of them, they get stored into the database. And so the user is able to, the polling function picks up these results and shares the results with the user. And the user further will copy, out of those 2-3 SCV codes, he picks up one of the codes and then copies and posts into another backend system to categorize the invoice. Now, the user response is also captured, and the responses are stored in our backend database. So finally, we have results from the model training as well as what was the golden copy results. So we compared. So there's a QA that happens which compares both the results, like how is the model performed. So therefore, we are able to track the model metrics, usage patterns, and various other attributes so that we can improve our model training as we go along. I think it's high time now that we take a dive into the nuances of the ML model journey that we have automated. So on this note, I invite Fernando to take over from here. Thank you.
Thank you, Shobha. Hi, everyone. Well, as we all know, when we are talking about machine learning algorithms, the most important prerequisite is to have a good data set. So let's take a look at what are the challenges of our data set that we came across. Starting with the OCR errors, that is the process of extraction of the text from the invoices. Here there are basically two formats for the input PDFs. They can be a readable digital PDF, which is not a problem to process, but they also can be scanned. So we will have an image of a PDF which contains skewness, and we need to fix. Also, we have the problem of time, so we need to find a balance between the time that every piece in our pipeline takes. Then the most important thing is that is the class imbalance. So effectively, our invoices are categorized under certain SCP codes. Now, as you can see, the total amount of invoices that we used for training was 92,000, and the total amount of classes among these 92,000 invoices is 79. From these 79 classes, 33 are correctly represented, which is a small percentage compared to the number of underrepresented classes. We say that a class is underrepresented when it doesn't have enough data to be trained. And also we have significant classes as well. So this is something we need to tackle straight away, because we have significant classes which are underrepresented, obviously. And finally, we have to face multilingual text issues, since the invoices can come in different languages. Our main approach here is to focus on using English text only, and then we also have to take care about the different currencies we will find in the invoices, since each of them will come with the standards of their own countries. And now we will talk about the solution to these problems in the next slide. Okay, so here we can see the flow of the data since the very beginning in the PDF invoices to the final model training. So in each of these phases, I will explain which are the solutions, which are the final approach that we are taking in each of them. So starting with the first phase, we have the text extraction. Obviously, we have to extract the text from the PDFs. And as we say, we are going to use a proprietary OCR tool. But obviously, this text is raw. It's not as useful as we would like to be. So basically, we have to pre-process it. So we go to the second phase. Here in the pre-processing step, we have applied to the raw text a combination of the most used pre-process and cleaning techniques to this raw text. Basically, we are removing punctuations, removing URLs, stop words. Also, we are lowercasing, tokenization, lemmatization. We are also removing jump lines, white spaces. And once we have a clean version of the text, we go to the third one, that is the text pictorization. As we all know, computers doesn't understand natural text, so we have to convert this text into numbers. In this phase, we have taken into account 4 different algorithms. We have test with word-to-back, back of words, TF-ID vectorizer, and also with fast text. And I can say that word-to-back is the one that is giving us the best performance among the others. And important to remark here that we are using 300 components for the feature vectors for the word-to-back. And once we have the feature vectors, we go to the model training. We have experimented with several algorithms. We have tested super vector machines, logistic regressions, neural networks, random forest, and finally XGBoost. But I will talk about the final solution and the different metrics that we got in this phase in the next slides. But now we are going to take a deeper look into the pipeline that in the lab environment. This lab environment, as Shobha mentioned before, it's at AWS SageMaker instance. And as you can see, starting from the beginning, we have the PDF files that goes directly to the proprietary OCR library. Here we are extracting the raw text, the unuseful text, and we have to pre-process it. It goes directly to the pre-process module, where we firstly clean it, encode it, and then we have to label it, to tag it. So basically, we are using the IDs of the PDFs. We join this encoded data with its specific classification, as we are going to use supervised algorithm. And finally, we are separating the final data into training and test datasets. For training datasets, we are using an 80% of the data, and for testing dataset, we are using a 20% of the data. And one more comment here is that from this module, from the pre-processing module, we are extracting also the .model file that it's a pre-trained model for encoding that we are going to use on the model serving module, obviously. And now that we have already the data, we have to train our model. So basically, we have to select a proper model that we want to test. We have to apply the cross-validation, hyperparameter tuning to get the best results, and finally compare the different performance metrics. And the outcome of this step is the final model and to deploy it. So basically, here we are extracting a .pickle file that contains the trained model that is going to be along with the .model file for the model service ready to use. And now, in the next slide, we are going to take a look at the different metrics of the different algorithms that we have been experimenting with. So as you can see here, we have the super vector machines algorithm, the logistic regression one, the neural network, the random forest, and finally the XGBoost. We are taking into account 6 of the most important classes in our dataset that are on the top of the table. And then we are measuring the precision, recall, and F1 score of each of them. And finally, we are measuring the accuracy of the whole model for each of the algorithms. So if we firstly take a look at the super vector machines and logistic regression, we can see that are not getting the best accuracies, neither the neural networks, and also we can see some kind of overfitting on some of the classes. For example, the 5, 3, 6. We can also see for the neural networks that we are getting a 0% of precision, recall, and F1 score also for this class, and a very unstable performance, because we can see this yo-yo effect. We are getting a high performance for the first class, for example, a high performance, then we go to 0, then we go up again. So we don't want this unstable performance. And finally, we go to our main focus, that are the decision trees algorithms. Firstly, focusing on the random forest, we can see a very clear overfitting in some of the variables. We are getting 100% of accuracy in this 536 class, and also a very high, extremely strange good performance in the 540, and then a very low performance in the 616 with only a 60% of precision. So basically, we don't want this behavior in our algorithm. We want a stable and good performance algorithm. It's getting an 84% of accuracy, but as I said, we are seeing some overfitting here. So basically, we go to the final solution, that is the one that we are taking, that is the XGBoost algorithm. We like to see it as an extension of the random forest that is getting a very stable performance for every class. Also, it's getting a good performance for every class. And finally, we are getting the best accuracy among all the rest of the algorithms. So this is the conclusion. And now Shobha, my colleague, is going to make a summary of all this project presentation. Thank you.
Thank you, Fernando. Thank you. Nicely summed up. So the key takeaways from this automation is automating the whole pipeline, the data ingestion part, which happens on a monthly basis. We also automate the user interaction through Liquid Design web application, web UI. And then we're using a trained supervised machine learning model to predict the SCP codes for invoice. And to convert PDF to text, we're using a proprietary OCR library. And the accountants pretty much upload the PDF and then get the results, the top 3 rankings, and then copy the SCP code and post it in another system. So we cut down the human errors here. And then finally, we capture all the model metrics and the usage patterns to monitor the model performance and look for quality data, any data bias in it. With that, actually, I would like to quickly showcase, give you a feeler for the user interface. There's a small video we're going to just play. So that's our single sign-on page and accountant for uploading the documents. And then that's dummy document here. Of course, you get a preview of the document, and then it's gone for processing to get the SCB codes. There you go. You got top 3 codes. Copy that, and that user response is captured by us to monitor the quality of the model. With that, I hope you enjoyed the presentation and you had some insights and some takeaways. I would like to take this opportunity to thank you.